So before we start our report, let us pray. Lord, please guide us in our reporting tonight and make everything successful. Amen. Next. So good day everyone. Good day ma'am. I am Roy Jemuel M. Siban and we are group 3. We are discussing lesson 2, colors of light found in visible spectrum up to lesson 3, importance of light in forensic photography. Next. So the order of color. The order of color, we have three main color. The primary color, the secondary color, and tertiary color. So what is the primary colors? These are the yellow, red, and blue. These three color are known as the primary RGB colors. So primary colors, these all colors spectrum come from combining at least two of them. So the other information about primary colors, it is impossible to combine primary colors with other use because primary color they serve as the foundation for other colors. The next is the secondary color. The secondary color is the visual stimulation of two different receptor cones. The example of secondary color, this is the combining of the primary color, the yellow into red into orange, red, blue into purple, blue and yellow become green. So secondary color is the one that is produced in a certain color space by combining the primary colors. Last is the tertiary. Tertiary colors also known as intermediate colors. uh, Indicates that resulting from the mix of a fully saturated primary color with another primary color. In short, you can combine the primary color into the secondary color. Next, what does color theory emphasize? So, color theory is a color that cannot be made from the combination of any other colors. This combination of the three main color, just which is the primary, secondary, and tertiary. So when these three colors are combined, they add up to white light. So white light is refers to wavelength between 400 to 700 are presented to the eye in early equal quantity. So other added information about color theory, this is a body of rules and principle that employs to engage consumers through visually appealing color schemes in user interfaces. Next, types of color schemes. So, what is color schemes? Color scheme is to to learn how to create balance to in color combinations. So, we have complementary colors. So, complementary colors are those found in the opposite sides of the color wheel. So, why is important complementary colors? Because complementary colors are so popular in photography because one, the juxtaposition of the two use results in the bold, vivid contrast. Next, colors that are complementary inherently balance one another. Then last, complementary colors simply look good together. Then analogous colors scheme are those that use adjacent hues on the color wheel. And this base is the primary colors that serve as the connection between all of them. But these analogous colors dominant hue might be the secondary color. Next. Next is the monochrome colors. So monochrome color schemes refers the composition that use the single hue with the variation of tones and shades. Last is the color variables, which refers to the colors basic color wheel into complete palette of the 10 million colors humans can see. In the color variables, we have three respectively uses: the hue, saturation, and luminance. So, what is hue? Hue is refers the radial position on the color of RGB color. Determine given the color like red, yellow, blue, or purple. Hue displayed in degrees ranging from 0 to 360 degrees. Saturation is refers to the purity or intensity of a color from scale 0 to 100. When you use 0 comes saturation level. The closer of the color is to grayscale. Then luminance, also known as brightness or value. Luminance determines how bright or color is. It ranges from 0 to 100 with 0 being black. Next. So the last is the advancing and receding colors. So advancing reading colors is a split between warm and cool colors. So warm colors tend to stand out, drawing our attention right away. So warm colors range from red to yellow, while purple to green hues are known as cool colors. So the example of advancing receding colors is the danger and stop signs are often yellow or red. So that's all part of my report. Next reporter, please.
Good day, everyone. I am Jester Angelo Dispo, and I'm going to talk about Lesson 3, Importance of Light in Forensic Photography. Effectively utilizing light will create an image that will give forensic investigators the ability to analyze details of a scene and evidence. Good lighting makes the characteristic of subjects visible and can make the nearly invisible visible. This is the goal of good lighting required for and use in scientific photography. Forensic imagery using artificial light must be carefully considered. Photographs for evidence need to be first and foremost about scientific data and not about an interpretation or bias. Object can be solid such as vehicle tires or shiny like or bullet casing, transparent like a glass window or water. Scenes may be somewhat flat and cover large areas that are challenged to illuminate. A scene's characteristics will determine how and which lighting style to use. Due to quantity of variables, a forensic photographer um, may be required to use multiple lighting techniques within the same scene or situation to highlight numerous details for analysis. Color, texture, shape, topography, cracks, or any other characteristic of evidence that are relevant must be distinct and measurable. Next, please. L- Lighting styles and effects. One tip to consider is to use a sturdy tripod for long exposures. If you are without a tripod, you must increase your ISO to allow a handheld camera shutter speed. It is also useful to use a fast lens and or prime lens that has a large aperture near f2.8 to allow much light as possible onto imaging sensor, which capturing an image make the light your friend. Situate yourself in a position where the light will illuminate your subject. Signage, street lights, reflected lights, and window lights are useful to capture the subject matter. Wide open apertures will create a low depth of field. So in this situation, maximize the depth of field by focusing on the primary subject at the scene. So frontal or direct lighting. Frontal lighting is created with the light behind or near the photograph's camera and lens that makes pictures look as though the light came from the camera lens itself or on axis with camera, like that of an on camera flash. The light the light on the subject is reflected directly back into the lens imaging surface. Frontal lighting is used to minimize shadows within the evidence and creates very flat texture image. This example is in this picture. Example of this is flash on mobile phone. Thank you. Next reporter.
Good day, classmate. I am Jason Dev M. Kaube, and my report is bounce lightning. Bounce light bounce lightning is placing reflective surface in the path of your lightning source, thereby pushing some of the light back into the subject. Bounced lightning helps to minimize strong shadow and creates a more lightning environment, which helps to bring out the smallest detail of the product, and a soft lighting style that reduces harsh shadow and creates gentle appearance. Next is next 45-degree lighting, one of the most common photolight replacements, meaning that light is placed at the 45-degree angle from the subject. At the 45 degree, you're most closely emulating what refers to remembrance lightning, which means produce natural and generally fluttering light of your subject. Changing the light and degree angle of your subject will be make highlight and shadows more prevalent depending on your your placement. Next, side oblique lightning. A light source of position at the low angle. Oblique lighting is the usually used to show the detail by creating shadow on the surface of the evidence. Oblique lighting is a commonly used to when photographing impressions, such as tool marks and certain types of fingerprints. A very low oblique angle of lighting can be used to photograph dusty, dusty footwear impression and intended rating. Next reporter.
Good day, everyone. My name is Carl Antoinette Maningo, and I will be continuing the lesson 3, letter E, backlighting. Backlighting can be important in forensic photography as it can help to reveal details that might not be visible in normal lighting conditions. By illuminating the subjects from behind, backlighting can create a contrast between the subject and its surroundings, making it easier to see details such as edges, contours, and textures. In some cases, backlighting may also help to reveal evidence that is not visible in other lighting conditions. For example, if a suspect's clothing has been stained with blood or other fluids, backlighting may help to reveal the presence of these substances, even if they are not visible to the naked eye. However, it's important to note that the use of backlighting in forensic photography will depend on the specific circumstances of each case. For example, in some cases, from lighting or side lighting may be more appropriate depending on the angle of the subject or the type of evidence being photographed. Diffuse lighting. Diffuse lighting can be very useful in forensic photography as it helps to reduce harsh shadows and glare. which can make it difficult to see details in the subjects. Diffuse lighting creates a soft and even illumination, which can be especially important when photographing evidence such as fingerprints, footprints, or other small details. Diffuse lighting can be achieved in several ways, including soft boxes or umbrellas to diffuse the light from a flash or continuous light source, or by bouncing the light off a reflective surface such as a white wall or ceiling. This helps to create a more even and natural looking illumination, which can be especially important when photographing evidence in order to accurately document in its appearance. Dif- and lastly, diffuse tent lighting. Diffuse tent lighting can be very important in forensic photography, particularly when photographing evidence such as firearms, tools, or other objects with reflective surfaces. The use of diffuse tent can help to eliminate unwanted reflections and shadows, which can make it difficult to see details in the subject. A diffuse tent is essentially a box or enclosure with translucent walls that allow light to pass through while diffusing it. By placing the subject inside the tent and illuminating it from the outside, and the light is diffused evenly around the subject, creating a soft and even illumination that helps to reveal details in the subject without unwanted reflections or shadows. The use of diffuse tint can also help to standardize the lighting condition for different subjects, which can be important when comparing evidence from different sources by using the same lighting condition for all subjects. It is easier to compare them side by side and identify the similarities of or differences that may be relevant to the investigation. Overall, the use of diffuse tint lighting can be a valuable tool in forensic photography, particularly when dealing with reflective or shiny surfaces, and can help to ensure that evidence is accurately documented and analyzed. Next reporter, please.
Good day, everyone. I'm Rafael Eric P. Bernas. I'll be reporting transmitted lighting. So, transmitted lighting is produced by the light shining through the subject and towards the camera and imaging surface. For this type of setup, light shines from behind the object, pass through it, and is received by the eye or a camera. So, for example of this is like the tinted glass of a car. If it is tinted, the light could not pass through pass through the tinted glass. It might be absorbed or it will be reflect. But if the car is not tinted, the light will be passed through the glass and it is called a transmitted light. Another example of this is, in other hand, transmitted lighting is very useful in determining watermarking and fiber arrangement. In the other example, for example, if this is like putting the paper in front of the light. So cashier, we always use it when we pay a cash in the cashier. They use the light to they use the light or put the money in front of the light to see if it is a fake or not. So that is transmitted light. So next slide please. The next slide ko. Thank you. So next is alternative transmitted light. An alternative method for forensic imaging or transparent object and specifically glassware is in the form of white line and black line lightning. This type of examination utilizes the inherent luminescent properties of materials like biological fluids, fiber, latent prints exposed to chromatic light to help locate these items. Alternative transmitted light has two methods. it has a two methods. White line and black line. So white line and black line methods. So white line lightning fi- uh, wait. White line glassware, if it is a bright light on the side and or on the surface of the glass subject close to the camera, then the lightning is known as a white line lightning. White line glasses White line glassware lighting is useful to reveal glass artifacts and, and edge definition. White line lighting is produced by placing a piece of black material behind the subject, then adding two lights outside the field of view. So we can see in the example, the PowerPoint, we can see subject has the subject glows it light on the edge. So that is the white line glassware. So next slide please. So the next one is black line glassware. Transmitted light that pass through the glassware and creates no reflection the camera facing surface produce a black line lightning pattern along the sides and edge of the glass. Black line lightning occurs because the light is transmitted through the glass without reflection. So black line glassware is the other side or the other or in Tagalog is kabaliktaran of white line glassware. It produce the edge will be black. We can see it in the picture. The picture of the cup, the glass of juice, we can see in its shadows, the edge of the glass was a black. So that was the black line glassware. So in my conclusion, white line and black line method of lighting glass can provide can provide different information about the evidence and the glass structure. Reflecting light through a glass or clear object contain defects or evidence on or within the glass creates a white line appearance and may perm- permit the photographer to record specific of evidence. Conversely, light being absorbed by the evidence and glass creating a black line while also permit the photographer to record specific evidence. Both method can support investigation and providing facts for the record. So the next slide please. So the last one of my report is pupil reflection in photographs could help investigators solve crimes. So Dr. Rob Hinkins of University of York's Department of Psychology published a study that showed how pupils in photography of faces can be mined for hidden information. The study simulated crime photo in which victims are photographed by attackers to examine the reflection in the eyes to those being photographed. So, eh, in in Dr. Rob Hinkins, um, Dr. Rob Hinkins' discovery is we can see or we can differentiate the actual scene of the crime through the reflection of its eyes. So if we capture a picture of a person in the crime scene, we can easily know what is the exact happening or exact person was present in that crime scene. So that was Rob Henkins' study. That is all. Next reporter.
Good day, everyone. I am the next reporter. By the way, my name is Patrick Carl G. Arieta. Refraction is the bending of light. It also happens with the sound, water, and other waves. And it passes from one transparent substance into another. This is bending by refraction makes it possible for us to have lens, magnifying glass, grimace, and rainbows. Next slide, please. Thank you. A path of bullet passing through window glass or bullet holes in glass. Glass broken through a projectile forms two distinct fracture types: radial fractures and concentric fractures. The radial fractures will often form on the glass side, on the opposite side of the impact, and will and will spread outwards from the point of impact. Concentric fractures on the same side of impact, and it will encircle the point of impact. Next slide, please. Thank you. The polarized light or polarized wave are the light waves in which the vibration occur in a single plane. Polarized light consists of waves in which the direction of above is the same for all waves. Imagine on the screen, on that screen, you have seen the plane polarized light vibrates only in one plane. Thank you. Next reporter.
Good day, everyone. I'm Albert Ayones, and I'm going to discuss the imaging on a crime scene in finding traces. First, observation. In the absorption or reflection mode, a crime scene is a very complex environment in which traces with the evidential value coexist with many items we do not carry any significant information of the event. Moreover, traces are often tiny. Sometimes the perpetrator tries to erase them, and thus their detection is not easy. An alternative to this could be illuminating with a color complementary to that of the surface, which will appear dark, whereas trace should stand out as a lighter feature. The choice of illuminating wavelength also depends on the trace which the investigator is looking for. For example, the UV visible spectrum of blood shows prominent absorption peak at 450 nanometer, illuminating the sample with UV light and observing it with a UV-sensitive camera. Performing reflective ultraviolet photography can be an effective way to improve the contrast. In some cases, traces which reflect UV light will stand on a UV apex surface. Next slide. Fluorescence. This is quite practical in some approaches, but they are not very efficient in detecting fingerprints or other kinds of important biological fluids, such as semen, vaginal fluids, or saliva. These are cases fluorescence is a very powerful tool. When we talk about fluorescence, its ability of certain chemicals to give off visible light after absorbing radiation which is not normally visible. The most commonly used practice is simply to dust the foam fingerprint with the fingerprint powders, especially fluorescent powders. The foaming method is a versatility and effective technique to develop the latent fingerprints on the virtually all substrates, especially rough surface. Next slide. Can fluorescence detect gunshot residue? It is yes, fluorescence can be used also to detect gunshot residue on the hands of clothes and suspected shooter. There are several different types of residues found about ammunition and explosives, which fluoresce. By using the tunable forensic light source, observation can be made on items without touching any surface to see if the fluorescent residue are present. The individual particles of fluoresce using the illumination between 450 nanometer and 500 nanometer, and also the use of orange filter. Next slide, please. What can ultraviolet radiation detect? UV radiation can be very useful for the detection of many other traces such as fingerprints. Visible fingerprints are left either by fingers touching malleable materials such as clay or mud, or by fingers stained by colored substances like paint or blood. They can be detected by illuminating them with a visible light or by taking pictures in the absorption mode, enhancing contrast with speck and substrate. For example, the investigators can use the UV light to see the visible fingerprints glow. This strong luminescence effect creates a great contrast between the paint and surface, which in turn creates higher resolution image, making analysis easier and more precise. Next, next slide. What can blue what can blue fluorescence imitation detect? The blue fluorescent imitation due to optical brighteners can be very useful for detecting traces evidence such as textile fibers or paint chips or smears. Moreover, the lack of blue fluorescence emission can also yield useful information such as in the case of counterfeit documents, where erasure or abrasions can alter the optical response of the paper substrate. In such cases, the paper illuminated by UV light will fluoresce, imitate, imitating blue light, and the alternation will appear as dark areas. Next slide. What can infrared light detect? For infrared examination, there are three key requirements. The first is infrared light source. The second one, infrared pass filter. And the third one is infrared sensitive camera. All of these are necessary to successfully visualize the differences in IR absorption in reflection, which can allow us to reduce the inference from dark or patterned backgrounds and clearly see the evidence on the surface. This effect is not always possible to achieve. Not all inks and dye reflect IR light, but exploiting the differences in absorption in reflection between our substrate and evidence can provide meaningful information that we otherwise wouldn't have to access. Next slide. What can chemiluminescence detect? Chemiluminescence consists of the emission of light triggered by chemical reaction. In other words, fluorescence can activated just by illumination with a light and proper wavelength for chemiluminescence interaction with suitable reactant is needed, like the chemical luminol. It is the renowned reagent for detection of blood on crime scenes. Luminol is and hydrogen peroxide are sprayed on the surface where blood traces are being searched for. If the blood present, the iron present is a hemoglobin will act as a catalyst. Next slide. Photographic techniques and documenting traces. In the previous section, several approaches have been described for detecting traces at a crime scenes. In a crime scenes, documentation is important as finding traces because most often the information related to the item depends on their location or on their relationship with other objects on the crime scenes. And that's the end of my part. Thank you. Next reporter, please.
Everyone, good day, ma'am. We're talking about absorption mode, diffuse reflection mode, and cross polarization in forensic photography. Absorption mode, a colored object or stain can be visualized, emphasizing it against the substrate where it stands. If there's a chromatic difference between the trace and substrate, then it is possible to enhance it with photographs in the absorption mode. The best approach of illuminating the surface with monochromatic light. Obtain the sustainable filter working in the dark is a suggestion for the best result. The color of light to shine on the surface must be complementary to the color of the trace and as close as possible to that of the substrate. Therefore, just the blue light reflected by the surface will be reached to the detector of the camera, and as a result, the stain will stand out as dark against in light background. The technique can be applied using filter to monochromatize illuminate, illuminating light and observing with an unfiltered camera or by the naked eye. Figure 13a. As an alternative, a filter can be applied to the object of the camera or the object can be observed through a filter while illuminating it with white light. Figure 13b. The former method is more efficient but must be performed in the dark. The latter has the advantage that can be applied in sunlight or in conditions or artificial lightings. Next, diffuse reflection mode. Imaging techniques which exploit the diffusion of light can be very useful of observing traces which lie on a smooth or very reflecting surface, or for enhancing their 3D structure. This technique can be applied either with monochromatic or with white light. The method works best, in fact, on smooth and dark surface which will absorb the most of the radiation, impinging on them reflecting the rest. The rationale of this technique can be understood if the two main mechanisms of reflection of light from a surface are acknowledged: specular reflection and diffuse reflection. When imaging the surface, it will be circularly reflected by its smooth regions, and it will be diffused by the rough regions. Illumination is oriented at an angle such as specular reflection does not reach the camera, where diffused light, which is directed in all directions of space, can be acquired by the detector. This way, the trace appears as the light feature on a dark surface. As evident from 16, illumination should be angled especially if it is of interest to enhance the 3D structure of the observed object. Oblique or incident light should be used in this case, and there is no need for monochromatizing. White light can be used. Next, cross polarization in forensic photography. Cross polarization is a technique used to capture backscattered light from the subject while dramatically reducing or eliminating direct planar light that is reflecting from a subject is primarily used in nature photography. This technique allows a photography to reduce or eliminate glare caused by flash commonly observed on oily, waxy, wet, or otherwise shiny surface. Application in forensic photography would be when photographing injuries on oily or sweaty skin, latent prints develop on shiny surface, patent prints develop in a shiny or oily medium, or any true glass cross polarization is particularly suited for autopsy photos. Cross polarization of the camera filter and flash can be established by holding a piece of liner polarizing acetate in front of the camera lens oriented in the same direction as the acetate over the flash head. Turn circularly polarizing filter until maximum darkness is observed. And that's my report.
So that's all report of Group 3. Thank you for listening and God bless everyone.